Hello friends, welcome to Geeks for Geeks. In this video, we will discuss the problem that is the number of bits to be flipped for the conversion of one integer into another. The problem says that given two integers a and b and we need to count the number of bits to be flipped to convert a to b. For example, if a is equals to 146 and b is equals to 137, then we observe several bits in a which can be flipped to make it equal to b. Those are highlighted here. Since these are 4 in number, we get 4 as an output for this example. Now, can you suggest any approach for solving the given problem? Well, here we just need to count the number of bits which are different in A and B, and those bits can be identified by performing the bitwise XOR operation between them. Hence, the two-step solution says take the XOR of the two integers in the step 1 and then in step 2 we just return the number of set bits in that. Note that the XOR operation gives 1 if the two bits are complementary and 0 if both the bits are same. Take the same example again. Here the XOR of A and B gives 1 for the bits that differ in A and B and 0 for all other bits. Now on counting the set bits in the XOR of A and B, we get 4 set bits and hence we return 4 as an output. That is, if these 4 bits are flipped in A, then A would become equal to B. The implementation of the counting the set bits can be viewed from one of the previous videos on Geeks for Geeks, whose link is also shared in the description of this video. As far as the complexity of the solution is concerned, since we perform the finite number of steps in calculating the XOR, after which we just need to count the number of set bits. Hence, the time complexity depends on the method we use to count the number of set bits. In the general case, using the Bryan-Kernighan's algorithm, we get the time complexity of the order of set bits in the integer. Also, here our space requirements does not grow with the input variables, so the space complexity remains big O of 1. That's all for now. Thanks for watching. Please leave us your comments.